All right, today we are on the fourth section of chapter 3. We're going to talk about solving logarithmic and exponential equations today. So you definitely need your calculators out. There's going to be some larger numbers, some decimals, things like that. So this is a throwback, of course, to some Algebra 1, Algebra 2 type of questions. Just seeing if we kind of remember these. Solve the following exponential equations by making common bases. So what does that mean? Of course, we're going to keep our 3x minus 6 here. You can rewrite 27 using 3. 3 to the third power is 27. So our common base, of course, 3, and then I can just set my exponents equal to each other. X equals 9. So clearly if you put 9 in for x, 9 minus 6, 3, we're going to have equal expressions on either side. Okay, let's take a look at B. So same thing, we want to make common bases. So I always try to work with a smaller number to rewrite the larger number. So I'm going to try to use 2. So I can just know, you might need your calculator for this, 2 to the 4th is 16. Don't forget your x on there. Now it'd be nice to get that 2 on the left side out of the denominator, that 2 to the first. I'm going to cross the fraction bar and bring it to the top, which then I'm going to change the exponent to a -1. Now I have a common base of 2. I can set my exponents equal to each other and just go through and solve for x. So -1/4. All right, definitely going to have to use some of this today. Rewrite the logarithmic problem into exponential form. So log, always start at the base. Raised to the opposite side equals your argument. And of course, you should always have a true equation when you are done. Yes, 7 squared does equal 49. So what are we working on today? How to solve exponential equations. The B part will be solving the logarithmic equations. So properties of exponential equations. Let f of x equal a to the x, g of x equal log base a of x with x greater than 1. So just some little preliminary information. All of these properties you know. If your base and argument are the same value, they cancel out to the exponent. Ln and e cancel each other out. Again, log base a and your exponential, long as they're the same, cancel out to the argument. E and ln cancel each other out. All properties we've seen, we might use some of these today. Now, same deal, if you have a log base a, they're going to cancel each other out. And if we just use this in the warm-up problem, your common bases, then the exponents are equal. All things we should know. All right, here we go. So here's some little guidelines to try to help you out a little bit. First, you always want to make sure your exponential expression is by itself. Should have put a longer blank there. Exponential. Sorry for my sloppy writing. Try to achieve a common base on each side, just like I did in the warm-up problems. Then set the exponents equal. Now, sometimes we cannot achieve a common base. It's just impossible to do it. So what I'm going to have to do is rewrite it in logarithm form. Because remember, the inverse of exponential is a log. And of course, we're going to make sure to use ln, natural log, if we have e to the x. Because remember, we can type logarithms of different bases into our calculators. All right, let's take a look. So first, it says without the aid of a calculator. So that's kind of your hint that you want to try to make your common bases. Now, you might need a calculator. Clearly, I'm going to use 3. You might need your calculator to figure out 3 to what power is 243. I just happen to know it's 3 to the 5th. Of course, I'm going to set my exponents equal. X equals 5. So I know it says without a calculator, but you might need it to help you out with some of those exponents. All right, let's take a look at D now. Or sorry, letter B. I'm going to try to use 7, of course, so I'm going to use the smaller number to rewrite the bigger one. 49 we know is 7 squared. I'd like to take that out of the denominator and move it up top, so then I'm going to change the sign on the exponent, and then I'm going to set my exponents equal. Got it. That wasn't too bad. Okay, C, same thing. I'm going to try to use the smaller number, of course, to rewrite the bigger one. So I'm going to try to use 2. So again, you might need your calculator for this. I just happen to know 2 to the 5th is 32. Now, I'd like to get that 2 in the left side out of the denominator. I want to move it up top. So then I'm going to change the exponent to -1. And of course, we still have the x there. And as always, I'm setting my exponents equal to each other. I'm just going to switch the signs on either side. X equals -5. All right, last one of these, D. Now, isolate the exponential expression. We haven't had this happen where you have this extra number. So the first thing I'm going to do is get rid of the 5. I can't make it 40 to the x. You would be breaking order of operations. So we're going to get rid of the 5. So again, you might need your calculator. 325 divided by 5, 65. Now, there is no way I can rewrite 865 as 8 to some power. 8 squared, 64, and 8 cubed is going to be higher than that. So remember, if you can't, I'm just going to back it up a quick second. If we can't, I'm looking at number 3, if we can't achieve a common base, we're going to write it in logarithmic form. So I'm going to put the log, base 8, and then remember the 65 and the exponent switch sides of the equal sign. We can't use a calculator, so I'm not going to type that in. I'm just going to leave it directly as it is. All right, here we go. Solve the given exponential equation. Round to 3 decimal places. So there's a big hint. We're going to have to be using your calculators on this. Now, I cannot write 3,000 as 6 to some power. So what I'm going to do, put it in logarithmic form. Log base 6 of 3,000 equals our exponent. And then, of course, to get x by itself, we're going to divide each side by 5, not x. I can't write and talk at the same time. You guys know that. Divide by 5. All right, so we definitely are going to need our calculators for this. We've typed these in before, but I'm just going to pull up this first one just to show you again how to do it. It's in your math menu, and you're going to right, or down arrow, I should say, down arrow till you see log base. Oh, went too far. Log base. Come on. There we go, letter A. And then we'll pull up the script and everything for you. So I'm just going to type it in 6 and then 3,000. I'm going to go ahead and hit enter, equal it out, and then of course I've got to divide it by 5. All right, and we're going to round to 3 decimals, so I'm going to put 8.894 for my final answer. Just one other quick thing to show you, of course, don't forget you can find that log base if you hit alpha y equals and right arrow over to function. You can see it's number 5. I don't know really what's quicker to access it, but there they both are. We've seen that before. So I'm just going to, let me jot down the final answer here. Got it. All right, moving on to the next one. So again, I can't rewrite, 0.0625 as a power of 4, so I'm going to put it in logarithmic form. Log 4 of 0.0625 equals your exponent. And then, of course, to get x alone, we're going to divide each side by -2. And I just showed you how to type those in your calculator again. Same thing. You end up with 1. Turns out to a nice whole number that time. I'm not going to punch in everyone, but I'll punch in a couple for you just to remind you. All right, this one a little extra step because you don't have your exponential expression by itself. You've got this 100 on here, so I'm going to divide it off. So so be thinking ln. 125,000 divided by 100, 1250. Okay, so again, I'm going to rewrite it in logarithmic form. So log base e, 1250 equals your exponent. Now, of course, we do not write log base e. We know that is our ln. And some of you can go right to this line here, right to the ln, of course, and then we're going to divide off 0.005 to get x by itself. So just to show you quick on this, of course, we've done these, but just to remind you, on the calculator, ln's on the left side there, ln of 1250. I'm going to equal it out and then divide by 0.005. And you can type it in all in one statement, just make sure you close up your parentheses. So let's jot that down. I'm going to round to 3 decimal places. So 1,426.180. Got it. All right, we got a little bit of work on D to get the exponential by itself. We need to get rid of this minus 14 or negative 14. So I'm going to add 14 to each side. 11 and 14, of course, 25. We also need to get rid of the 3. Some of you can do that all in one step. Now, same thing. I'm going to rewrite this in logarithmic form. Log base e, 25 thirds equals our exponent. And again, log base e is really ln. So we're going to hit the ln button on the calculator, 20 thirds. You can punch that one in. That's super easy. Round to 3 decimal places. Got it. All right, a lot of calculator work today, my friends. All right, similar, same deal. We need to get this exponential, the 8 to the -2 minus x by itself. So first I'm going to subtract the 15 off. Remember, you cannot multiply the 6 and the 8 together. You would be breaking order of operations. Just like the last one, I'm going to get rid of the 6 and divide it. 2,586 divided by 6, 431. And then of course, I can't rewrite 431 as 8 to some power, so I'm going to convert it into exponential form, or to logarithmic form out of exponential form. 431 equals our exponent. Okay, so we're going to do just a smidge, a little bit of work to get x by itself. We're going to add 2. Now, of course, when you punch this in your calculator, I'm going to type this one in really fast. Don't add the 2 and the 431. They're not like terms. I'm first going to do log base 8 of 431. This time I'm going to do the alpha y equals and go over to function and then number 5. So I'm going to do log base 8. I'm going to type in the 431. You can, of course, close up your parenthesis. I'm just going to equal it out. I'm going to, well, we shouldn't have to add 2 in the calculator. Should be able to do that mentally. 4.917, I'm going to round that to. And then, of course, I'm going to get rid of this negative. I'm just going to switch the signs. Got it. All right, F is kind of a tricky one, and there's just one like this on the homework. You might look at this and be like, oh, there's 2 E's in it. It does get a little dicey. This is a trinomial, 3 terms. So believe it or not, we can factor it. So first I'm going to do the numbers. What multiplies to negative adds to negative 1. Nobody gets that wrong. Now, we're not going to just put x in these. It's going to be e to the x. E to the x. Because, of course, when you FOIL this out, you would add these exponents when you FOIL. 1x, 1x, 2x. So just like any time we factor, we're going to set each factor to 0. I'm going to isolate the exponential expression. So on this first equation, we're just going to add 3 over. And this guy, we're going to subtract 2. And of course, we're going to convert them into logarithmic form. So log base e of 3 equals the exponent. Again, some of you can skip this step and go right to ln of 3. You're going to punch ln of 3 in the calculator. You get 1.099. Okay, this one, again, same thing. You'd convert it into log form, base e, negative 2 equals the exponent. Log base e, I'm a little worried here. We cannot do the log of a negative number, because remember, logs are really exponents. If you have a negative exponent, it's fraction. It won't give you a negative answer. So we're not going to yield a solution out of this one. So I'm just going to keep the 1.099. If you try to type in ln and negative 2 in the calculator, you'll very clearly get an error message. All right, this one just looks kind of crazy, but same principle. We want to get this exponential piece by itself. So first I'm going to get rid of the 250. I'm just going to divide that off. Of course, you can just do that part in your calculator. 1 plus 0.01, I'm just going to go ahead and add that. Okay, 150,000 divided by 250. Punch that in the calculator. It is 600. Now I'm going to get rid of this over 0.01 by multiplying by that on each side, because we are isolating our exponential expression. 600 times 0.01, 6. And now I'm going to convert this into log form. Log base 1.01 looks like it's just a decimal equals our exponent. And you would simply type this into your calculator, and you end up with 180.07. All right, a lot of calculator, a lot of decimals. Be careful on your rounding as always. Have a great day.